This is a presentation of Orcatech's standard solution for the engineering in the mining and minerals industry. It contains features and data to cover the complete workflow from the flowsheet down to the circuit diagrams and following documents of the electrical components. We start with the creation of a flowsheet. That doesn't have to create it manual in all details. We can use predefined circuit components from a template project. These templates contain the complete graphic, as you can see in the preview, and also the structured data behind. We just drag and drop it onto the drawing and we see what it contains. If necessary, we modify the name of it. The name is the unique designation in the database. We can combine this with a lot of different predefined circuit components. For example, the belt conveyor. We just drag and drop it onto the drawing as well, in the same way as we did before. If we don't know the name at the moment, we just skip to go on with the graphical design. We can combine as we can combine it in all kind of office conformity programs. At the end, you will get a structure number of data in the database that contains everything from the functional point of view and also the physical point of view, the devices itself. We come later to it. In the graphical design, we can also connect them via a standard tool. We just use the connector tool to start a connection from here to there. We complete it in that way. It's very easy to define a connection from one device to another one, just in the same way as you use it in Visio or other Office programs. Predefined circuit components are very comfortable, but they are not fixed. They can be modified in each single detail information so that you are able to make the drawing to what you want it to be. So next step is that we can define what materials are used in that flowsheet. For that we have material information in the equipment folder. They are sorted in different folders and it is quite easy to select one and drag and drop it onto the drawing to associate the connections. We drop it on the first connection and we get a list of where it is used, and we also can see that this connection is switched down to all connections that are related to. And here, from here on, we can see all the technical details of that material. If it is necessary to define mixtures of materials, it's quite easy to create just one new material in the structure of the material folder. You just have to select the type of the material, type in its name, and then on this you can start the potential assignment wizard. This assignment wizard enables you to combine different materials in that very easy way, and if you assign and close, you will see that all these materials are linked together, and that you go on in the same way. Just drag and drop this onto the drawing, and then you have the information of the mixture of that materials on that connections. Now we can have a look at the structure of the functional view of all the data that are in the database. As you can see here, we have different machines, and there is a hint from the system that it shows there are two machines with the same name. That is not a fault, but a feature. Engineering base keeps it every time unique. You can see that you have different structures, subfunctions, and here you have one level more. It is just information for the user that a belt conveyor and also the scratcher belongs together. To get rid of that conflict, you can use a feature called breakup component that takes care about the uniqueness and also the numbering of the machines. The sequence of the number is modified and it is taken back to the drawing immediately. The next feature is very helpful for suppliers who have different designation systems than the customer. The unique name is shown in the tree, and also if you open a worksheet for these machines you can see the unique names, and here you can enter your own designation systems. By using just this one feature, change the supplier code, you can change the unique name in the tree and in the graphics in one step. You can see that the information is just switched. Now you can go on with the specification of the machines, and after you have done this work you can switch it back in the same way to make sure that you can send the designation system of the customer to it back. The next step is the specification of machines. It's quite easy to create data sheets just by selecting the machines, click the right mouse key and create the data sheets automatically. All available information of the machines will be put onto drawings that will be associated to the object. If we open it, we can see that we have just a few information that are very basic. The reason is that we don't have a lot of attributes to fill. The reason for that is that the project is at level 0 at the moment. If the engineering starts, just a few information has to be filled. In later state of the engineering, another level should be set, and in that moment we have the chance to type in more detailed information. If so, we just need to run this feature again. We create a data sheet and then we will see that we have a lot of more attributes on the sheet. Without modification of the templates, you just have to do this one click to create the data sheet. These data sheets are designed dynamically. And now you can go on with the specification of your machines. You can type in the detailed information from the drawing, from the worksheet, from the tree, wherever you want. It's up to you where you and how you go on with your engineering. In case that you don't put in all the detailed information by yourself, you also have the chance to export data to sub-suppliers. For example, if you don't create belt conveyors on your own, you can use the Smart Excel export and import feature to send the necessary information to sub-suppliers that will fill the information into Excel sheets to send it back to you. Just select the name of the file and select the orientation of the Excel sheet and export. It's done very quick, and then we can see how it looks like. We can open the Excel sheet and we can see that we can type in some more technical information. We just need to save this, and then in a second step we can re-import the information that come from the sub-suppliers. Just have to select the files. We can have a preview of what has been modified. In that way we can see what information has been changed, and after that we do the import, and there you can see that immediately all the information is put in on that sheet and on the drawings as well. For example, the flow sheet, there you see all your detailed information. Now we can go on with the specification of electrical equipment that are necessary to drive the machines. For that we also can use an engineering-based worksheet that gives you an overview of all necessary information. There you can type in a very easy way the required values. It's also possible to use Excel-like features as the autofill. It is a very helpful feature to fill very quick. So specification in that worksheet is one thing. Another feature could be that you want to have a detailed overview of all the attributes for a single motor in a, let's say, single specification sheet. This is also possible just by creating a particular motor data sheet. You just need to create a new sheet for a description of a motor like that, and then you just need to open it, and you can associate this drive just by using drag and drop onto the drawing, and you see the detailed information there. So you have your device related data sheet. This might be necessary for big drives, and it's also possible to have specification sheets for multiple devices. So for example, if you have a worksheet for small motors, then it's quite easy just to select the number of motors that you want to associate it, and then you can run the specification wizard. You just need to select the motor that you want to use for that. Say select, and in that moment you will get an additional list of what motor will use this particular specification. This is very helpful for devices that are used very often, so you don't have to create a single datasheet to each single device. It saves your money and it saves paper. All the specification sheets have direct accessibility to the database, but sometimes it can be helpful to have just a list in Excel. In that case, you just need to click once. You will get an Excel sheet for motors immediately. You just need to open it to see how many motors with what power you need. The next list might be the asset list. Asset list is also very helpful. The asset list contains a list of drives and sensors and a summary list of power and also required inputs and outputs for the control system. This list can be the start point of the engineering of the electrical equipment. Now we can have a look at the infrastructure of a plant. This could be the next step or parallel to it. In that case, we imported a plant from the bird's view. It is originally a DXF file that we imported, and we can add it with logical information from engineering base. For example, we have the overview of the tank of the two belt conveyors, and here we can define the infrastructure with location frames. We just can open it to see what it is in detail. We also can navigate to its representation in the equipment folder, and there you can see the structure of the plant. It's also possible to see where it is shown as well. For example, in another drawing where you can have a detailed view on that. Here you have the sequence of these two belt conveyors and a tank, and there you have the representation of this location. If there is a location missing, it's quite easy just to drag and drop the object to associate the rest of it. And if you want to create a new one, you just need to draw with the graphic feature, draw a rectangle, select the field box and the frame connector, and then you have completed your infrastructure. Another feature is that you can create electrical flow sheets or single line diagrams. We will have an overview of that by selecting that. It's also originally imported via DXF interface, but it enables us to complete the engineering in different ways. For example, we can use the objects from the functional point of view to complete it with that kind of shapes. Just use drag and drops of the objects, and then you will get the information of the objects that you want to show. You can create your single lines in Engineering Base completely. And you can also combine this with equipment information. For example, if you plan your MCCs here, you just need to drag and drop it to the devices, and then you get a message that it is shown on another drawing. It's not a fault, it's just a hint that we can follow. Now we have a link to the MCC, and we want to have a look where it is shown as well. Here we have the overview of a cabinet where the MCCs are located. At the moment they are not used, but that is one thing that we want to complete in the next steps. At the moment these MCCs are just empty slots. The racks, means the devices, come from the circuit diagrams of the motors that we defined in the flowsheet. Engineering Base gives you a very helpful tool to create such circuit diagrams from templates. Let's have a look at those templates to have an overview of what it contains. We have a typical project where all these loads are defined that we can use. Those typicals are also organized in functions that contain all device information and drawing information that are required. All wirings and also all signals are defined. This is a preview of the drawing that will come if we use those typicals. Now we just need to go back to the list of motors to associate what typicals should be used. We switch to the plant, open a worksheet for functional devices, and here we have a very good overview of the motors where we can define what typical can be used. The typical can be selected direct from this point. The name the name is put in automatically. We can select different one. We can use the autofill function to complete it. Another feature is that we can define in what locations the devices of the typical should be placed. And there we have the chance to have accessibility to the complete location structure, and there we can define to what location the objects should be placed. Now we are ready to copy the typicals into our project. To make this visible, I navigate to the functional point of view. At the moment we just have the definition of any motor. From this point on we start the typical copy feature that enables us to select multiple functions that should be supported with a typical. Just by clicking the OK button, the typicals will be copied and the objects will be added, as you can see in the preview now. It takes just a few seconds to complete the data with all required information. Sheets, wires, cables, signals, IOs, devices, everything what is in the typicals will be added to these functions. It is a very fast way to create your circuit diagrams, and it helps you to standardize your information. Now we can go back to the drawing with the MCC to have a look for how we can combine this information. The MCCs are still not used, but if we have a look at the cabinet, we can see that we have a lot of devices associated to that. From here on we can start the merge device wizard. That gives us an overview of what devices can be used in other devices. For example, here we can select the MCC and there we see the list of slots that are not used at the moment. Here we have the devices that come from the circuit diagrams. And just by selecting the slot we can merge it. That means one is not available any longer and this is used. That will be shown in the drawing immediately. We can use it to select with selecting multiple of it, and then in a very single way we can use this MCCs. You have always the best overview of what MCCs are used with what motor and what are available. Using this wizard you can always be sure that you have the best practice and you have the best result for your hardware engineering. We can use the same wizard to associate this, the inputs and outputs that are not used at the moment. So if we have a look on the PLC card with the channels that are not used at the moment. For that we use the merge device wizard again. We have a look at all inputs or outputs, so you have always a good overview of what is available and what is used. Selecting the inputs and outputs is also very easy, and you can select your PLC card, but at the moment it is not possible to associate an output to an input. In that case it is. If you select the right matching devices, they will be merged. For the inputs we do the same. We select the PLC card, select it in that way, merge, done. Very quick. So here you have a list of the PLCs, what are used and what not used, and if you click on the overview, it will be shown here in that way, and it will be shown in the circuit diagram as well, where the information is coming in automatically. Now we have completed our workflow from the flow sheet down to the circuit diagram of the electrical components. From this point on you can create all the following documents that are necessary to describe everything for the manufacturing. You can create parts lists, terminal block diagrams, directories, overviews, what else? It's up to you. You can do everything with Engineering Base. You just need one tool. Everything is in. in the standard solution for the mining and minerals industry.